Okay, let's go through an example here in Station 6, which is kind of some key features of how to graph. And I'm probably going to have to use this space up here for some of my work, but let's see how this goes. So right here in this very first one, this is the quadratic that I'm going to use to answer all of these questions. So question number 1 is about the transformations. So remember, everything inside the squaring moves left and right. So a +3 would move the graph to the left 3, and then a -2 on the outside would move the graph down 2. So because of that, if I go left 3 and down 2, if you just think about that here, I'm going to start at the origin, that's where the parent function is. I go left 3 and down 2, my new vertex is now at -3, -2. Okay, and I've gone down here on my graph and I've plotted that point. So from the origin, I went left 3 and down 2. The axis of symmetry is this vertical line that goes right down the middle of a quadratic like this. So you'll notice it goes through the vertex. So it's always x equals, and it always equals the x coordinate of the vertex. So the x coordinate of the vertex is -3, so this would be x equals -3. Okay, so to find the y-intercept, we give you a hint here. It says make x equal 0. So I'm going to go to my quadratic, and it says x plus 3 squared, so I'm going to do 0 plus 3 squared minus 2, and I'm going to figure out what that is. So 0 plus 3 is 3 squared, and then 3 squared is 9, and 9 minus 2 is 7. So my y-intercept is at 0, 7. So I'm going to go over here and plot the point 0, 7. Now this is going to help me with my graph, because if you think about this blue point here is 3 spaces away from the axis of symmetry. And since a quadratic is symmetric, there should be another point 3 spaces away on the other side. So I only found this point, but now I know this other one, and that should give me enough information to do a really rough sketch. Forgive my poor drawing, but a really rough sketch of that quadratic. Okay? Okay, so the domain is left to right, and hopefully by now you know that the domain of every quadratic is -infinity to infinity. But the range is lowest to highest. So this graph goes no lower than -2, but it goes up forever. So that's -2 to infinity. Never equal infinity, but we do equal -2, so we're going to put a bracket there. Okay? Okay, this graph has a section where it decreases and a section where it increases. So I'm going to trace over here. If I go left to right, it decreases initially. So it decreases from -infinity until this x value. And if I go up here to my graph, that x value is -3. And then the next section over here, it increases. So it starts increasing at -3, and it increases for the rest of the graph. And then the last piece is the end behavior, which is what happens on both ends of the graph. So as x goes to infinity, which means to the right, so as I move to the right on the graph, my y's go up to infinity, and as x goes to -infinity would be to the left. So if I go to the left on my graph, my y's also go up, so that would be +infinity. So in the you try section right now, there are 2 more examples for you to try. So give those a try, and good luck.